project is for SIAT 333, the interaction design course, where the idea is we study a group of people and come up with something that they need. And we ended up studying a band, and what they needed was some form of way to collaborate without being able to meet all the time, because they're busy people.
And in this course, the real idea is to get students to learn what it's like to design with and for the people, for which they're going to design software, or they're going to design tangible objects, they're going to design mobile apps. That is, design with in mind who is going to use these things, who will value these things, and why and how they will value the things that they design.
And you think it won't be helpful, but you get insight that you totally wouldn't have gotten through like a typical questionnaire and interview.
You really open up the insight of how important the initial research is for the end result.
So for our project, we chose to do a Game of Thrones themed immersive environment. And as part of that, we wanted to create kind of like a large war tent. We wanted to go for kind of a sensory deprivation thing, where we take them out of all kind of the noise and stuff in this lobby and take them right into the game so they're not as distracted. The experience inside for the game is that for anyone who follows Game of Thrones, the plot of our game loosely follows the journey of Robb Stark.
Right, so this is a course about immersive environments, and the big goal is really to try and help people learn about immersion, how you can immerse yourself, the different components, a bit of the theoretical frameworks behind it, and then apply this all in one big team project.
Pretty much you learn the different aspects of immersion, which is audiovisual, challenge, and imaginative. You're taught Unity throughout the term, and it's really helpful.
Yeah, I would absolutely recommend this class. You're forced to make something for your portfolio, and you're forced to learn a lot while you're doing it, so it's absolutely an amazing course to take.
We're making this bio lamp. It's for off-grid project, and then we're designing this lamp for third world countries. So basically our concept is to power a lamp that's powered by dirt, and so it will give them unlimited electricity resource to power up anything that they need.
It's a course that helps students develop an understanding of design materials and also how to select various design materials for different problems, design problems. We give them a good overview on organics such as woods. We look at plastics.
Just being able to like really make something, print it out, like 3D model it, print it out, test it, see if it works, and then use what you learned to forward into your next iteration. It's really helpful, and it's just a testament to like fast prototyping and getting to where you want to go faster.
So this is my project. It's called Generative Serialism. So I'm taking video coming in and mapped it to different sounds. So the blue values increase how fast it's played and the velocity of everything, and then the green values play the range of the tonal values, and then the frequencies are changed by the red values. I went into it wanting to know about how sound design for video, and it was quite interesting. I learned about sound envelopes and stuff like that, and ADR, and it was interesting as a whole, and learning something I've never learned before.
Let's scan my hand, so let's scan my thumb here. See, it should start appearing there somewhere. Yeah, I can see my hand there kind of appearing and my thumb and stuff. I just try and keep my thumb out of things My hand. Yeah, keep it out of trouble. But yeah, no, it'll scan your hand or whatever happens to be in the path. It's a class 2 eye safe laser, so it's okay to. You wouldn't want to shoot somebody in the eyes like on purpose, but it's not going to hurt anything. But we can scan skin.
An AMT is an automatic mechanical toy. This is for our first year course. Think about high school students coming into university. Everything is handmade, and as you can see, there is a translational movement right here, and the gears are spinning, and the rotational movement, which is right here. Everything is handmade, so you can find this at home and make it yourself kind of thing. And we painted over everything. Took a lot of effort to do it. Definitely. A lot of trial. Yeah.
Okay, so this was Robot Showdown. It was an exploration into a physical interactive game. And so really it's just laser tag with I guess we can tag them with a laser. So we got this little laser at the top that can shoot. You can sort of see in the video. And you can also tag them by hitting them on the side. Basically, I think it's really interesting because it's controlled wirelessly. And it's got this little module, and it communicates with a relay station. And this relay station then communicates with the server computer. So as you see in the video, we've got a main computer in the back here, which is obscured right now. And that main computer keeps track of the score, time, and whenever anyone gets hit.
Our project is called Run DC, and it was done for IAT 330. Our project is a data visualization system for runners. We want to find a way that runners could take over a city by redefining the geography, by the decisions of where they go. So it takes GPS data and tracks it and visualizes it in a way that sort of redefines the landscape.
And in our case, we chose to use Washington, D.C. because it's one of the most well-defended cities in the United States, with all the military organizations and everything that's going on there. As well, it's rated one of the top running cities in the United States. You want to go for a run, so you say go for a run, you turn it on, and it plays you music, and it does whatever. And it tracks your GPS, so it tracks every little location that you go to. And every 10 seconds it takes a GPS coordinate. You get height or altitude, you get speed, all these kinds of things. And then when you get back, okay, you say, okay, great, this is my run, and you sync it with your Nike servers. So we go and pull all that data from the Nike servers, and we pull it down into our program, and we create visualizations based on that data.
The project's called Slug Robots. It was done for IAT 337, which is representation and fabrication. So the project brief for this was to create a kinetic sculpture that balanced nature and technology. So we took a traditional music box and slowly worked on it until it became a walking, moving slug. No, we made a gangster rap music video. Yeah, they have infrared. Once it's drawn enough,
This is form exploration and lighting design. What we have is we took this regular printing paper and we laser cut the perforation so that it was easier to fold, and it left us with a very versatile form here. Like you can compress it, you can expand it. We had it over top of this to show different aesthetics for it. But what we're trying to do is to find the most meaningful application for it. Some of the applications we have were where if you squeeze this together, it lights up where the copper points meet. This is light sensors. It's a bit dark, so it's already on. But what we're looking at as well is different ways to get the form to hold itself. So we looked at magnetic. We looked at magnetic paint to see if we could get the form to hold together. But what all this was just for was this. All of these were for user testing. We just wanted to ask people what would they do with this in a living setting. Like if this was somewhere where you got everybody eats and talks and you do your homework, what would you do with this?
Our project's name name is Envela. It's from IAT 320 Body Interface. When we designed this dress Envela, we have one research question in mind, and that is, for the user, what does it mean to be protected? How can we portray the idea of safety and protection for the user? And so in our initial research, we looked into different animals like the pufferfish and the lizards. So it opens in size, it fans out, and hopefully that increase in size will scare the opponent away. But unfortunately, we're not fishies or we're not lizards. We cannot connect to those gestures. So we went back to human beings. So what does it mean? So the answer is actually very subjective. Safety is a very subjective feeling. But we find that one gesture, one answer might be very simple. It's one simple hug. When you're scared, nervous, or when you're in need, that one simple hug can really do a lot of work, speaks thousands of words. And so how does it work technically is you have these users wear the sensors underneath the shirt. It takes the user's heart rate and averages out and use that as a threshold. When it feels like, when it says that the user's heart rate goes beyond the threshold in a very short period of time, it will fan out. But when your heart rate goes below the threshold again, the computer will sense it as the user's being normal again, and it will close this once again. So when it opens, we want to create the idea of making space very personal for the users. And at the same time, when it's opened, my user experience is I can hear a lot better. And in a different perspective, when people see this dress, you see this dress opens up, hopefully they will be intimidated